All right, hello again. We're going to go over lesson 6.5 now, which is all about area formulas. So let me get these notes pulled up. The nice thing is most of these you should have seen before, but we're just going to kind of take a look at them again to make sure we understand the different parts of the formulas and what we need to focus on whenever we do the calculations for these. So the very first one, we were looking at a triangle, which you should have definitely seen this formula before, but it's 1/2 times base times height, or you could even do base times height and divided by 2, right? Dividing by 2 and multiplying by 1/2, that should be the same thing. So just to take a look at an example here, the main thing whenever you're finding the area of a triangle, you have to understand what side is the base and what's the height. So one major thing to always look for, height should always be perpendicular to the base. So wherever you see a 90-degree angle formed, those are the two sides or the two units of measurement that you need to use. Okay, so in this particular triangle, they gave the side of 6 inches, they gave 8 inches, and then the bottom's 11 inches. And on the inside of this dotted line, that's 4 inches. But if you notice that dotted line, that's connected to the 90-degree angle. This dotted line is technically the height of the triangle. Okay, so we're going to use that 4 as h. It is perpendicular to the 11, so the 11 is going to be the base of the triangle. Okay, so for our formula, they did 1/2 times 11 times 4. 11 times 4 is 44. Half of 44 is 22, so the total area is 22 inches squared. Another big thing to point out or mention, I know you guys have done this before, but whenever you're finding area, it's always in square units. So whatever kind of measurement it is, you'll put the unit and you'll put a little square after it. Okay, and if they don't give you units, then you have to write out the word unit and put a square after it. But hopefully most of these will have some kind of measurement with it. Okay, the second example they give you here, if you notice in this triangle, so they gave you 15 centimeters, 10 centimeters, and 12 centimeters, but way over here is this little drawing of some dotted lines, and 8 centimeters is given with a right angle. So the height of this particular triangle is this 8 centimeters. Again, height and base have to be perpendicular. So 8 is the height, and then the side that went along or followed the other dotted line is the 12. So the 12 is actually going to be the base. So when we put this in the formula, 12 times 8, that would give us 96, and then half of 96 is 48 centimeters squared. Okay, again, notice how the little square is after the centimeters. That's talking about area. Okay, so there's a couple of examples there. The next thing we have, the area of a square. Well, technically, for a square, it should be side times side. But as you know, because we've gone through all the properties, all the sides of a square are the same. So it's also saying that side squared is another way to calculate it instead of having to do side times side. So something they could do, this one says to find the perimeter of the square if the area is 144 inches squared. So basically, they give you the total area. You have to find the side length, and then once you find the side length, you can find the perimeter. Okay, so kind of using these little formulas over here, if A, the area, is 144, and that's supposed to be side squared, in order to find each individual side, you would have to square root. Okay, so the square root of 144 is 12. That means every side of this square is 12 units, okay, or 12 inches. Okay, so in order for us to find perimeter, so remember, perimeter, you're adding the sides together. Well, if every single side is 12 and there's 4 sides, you could also do 4 times the side. So 4 times 12 would be 48 inches. Notice this is perimeter. Perimeter is not in square units. It's always in single units. So this is just 48 inches. That would be the final answer for that problem. Okay, so do pay close attention to your instructions and what you're finding whenever you go through your problems. Okay, the next shape we have is a rectangle, and rectangle is pretty basic. It's just base times height. So in this particular one, it says the area of a rectangle is 42 meters squared. Find the perimeter of the rectangle. So again, they give us the area and they want us to find the perimeter. So we have to start with the total, the 42. And we know 42 is supposed to be base times height. Well, if I look in this picture, I don't have my base, but I do have my height. Okay, so I should be able to find that base. And once I have that base measurement, I'll be able to add all my sides together. Okay, so 42 equals b times 4. If I divide by 4, b should be 10.5. So this base side right here is 10.5 or 10 and a half. Okay, and we know from a rectangle, like all the properties of it, its opposite side should be congruent. So if this right side is 4, that means the left side is 4. And if the bottom, we just found it to be 10.5, that means this top side has to be 10.5. So I have two 10.5, so 2 times 10.5, that would be 21. And then I have two sides that are 4. 2 times 4 is 8. If I add those two together, 21 plus 8, total perimeter for my rectangle should be 29 meters. Okay, again, it's in single units. There's no square units there because we're finding perimeter. Okay. All right. The next shape, a parallelogram. Okay, so a parallelogram actually has the exact same formula as a rectangle. It's base times height. But the main thing is, just like in your triangles, you have to make sure the base and the height are perpendicular to each other. So you have to make sure you see where the 90-degree angle is so you know what sides are the base and the height. Okay, so in this particular example, it says find the height of the parallelogram if the area is 60 feet squared. Okay, so they gave us this base measurement, and they said it's 10 feet. This says it's h. We don't have that measurement. Remember, in a parallelogram, its opposite sides are congruent, so this 10 would also be here at the top. So I know that it's okay to use that for my base. So if I set up my formula, 60 would be the total area, and I set that equal to 10 times h. All you have to do is divide by 10, and you get your h. Your h would have to be 6, or your height of the parallelogram would be 6. So that is one way to kind of use this stuff. So just make sure, again, you read carefully as far as what you're given in the problem and what you're trying to find so you know where things end up in the formula. Okay, this isn't going to be like, here's the information, find the area every single time. Like sometimes you have to find other information. Okay, the next shape that we're going to look at is a trapezoid. So for a trapezoid, the formula for area, so if you remember, for your trapezoids, you have two bases. They're the two sides that are parallel. So you have to add those two bases together. You're going to multiply by the height of the trapezoid. Again, look for a right angle. And then you're going to divide by 2. Okay, so we're going to do that for all of our trapezoids. So the first one, it's pretty straightforward. They give you the info. They just say find the area. So my two bases, if I look at my two parallel sides, it's this 10 meters and this 14 meters. So I got to add those two together. And 10 plus 14 would give us 24. Okay, the height, if you notice, it's the side with the right angle. It's 5 meters. So we would take that 24, we would multiply that by 5, which that would give us 120, right? Yes, the 120, of course. And then we would take that 120 and we would divide it by 2. So 120 divided by 2, that would leave us with 60 meters squared. That's the total area for this trapezoid. Remember, area is always talking about the space within an object, like how much could I fit inside, kind of, if it's a two-dimensional object. So that is the area for that top trapezoid. Now this bottom trapezoid is a little bit different. Okay, so they want us to find the height if the area is 32 meters squared. All right, and if you notice, they gave us the top base and the bottom base. They did not give us any measurement with a right angle. Okay, that's the thing we're trying to find, is that height. Okay, but we have enough information to find it. So we have our 32 meters. We need to plug, or meter squared, that we plug that in for area. That's the A. H, well, that's the thing we're trying to find, so it has to stay H. And then 11 plus 5, because 11 is the top and 5 is the bottom base, so we add those two, and then the divide by 2, that's always part of the formula. So if we have 11 plus 5, that's 16, and that's going to be 16 times H on top. Then for that 16 times H, I can take the 16 and divide it by 2 since these two things are being multiplied together. So 16 divided by 2 would simplify to be 8. 8 times h is supposed to equal 32. So for us to find the height, all we have to do is divide by 8, and 32 divided by 8 is 4. So the whole height of this trapezoid, if we were to draw in a dotted line with a right angle, it would be 4 meters. That's our final answer. Okay, so again, be really careful about where you plug in information when you're using the formulas. Okay, our next shape that we're going to talk about is a kite. Okay, so for the formula for area of a kite, you're going to see this D1 and this D2. D1 and D2 are the diagonal lengths. So you actually don't use any measurements from the outside of a kite. You have to use its diagonals. So the formula is we take one diagonal times the other diagonal, and then we divide by 2. So this one says to find the area of the kite if AE is 6 inches and BD is 20 inches. Okay, so A to E, if you notice right here, that's only part of a diagonal. Okay, but if you noticed, AE is half of AC. Okay, so remember, this diagonal, like since it goes through the two angles that should be congruent to each other, its opposite diagonal is actually going to split it in half. It's actually going to bisect it. BD is not bisected, but AC is bisected. So if AE is 6, that means the other side is 6, and that means this whole diagonal has to be 12. Okay, so I'm going to use that for diagonal 1. And then BD is 20, so B all the way to D, they gave us that measurement and said it's 20, so I use that for D2. I multiply those two together, that should be 240, and then I divide by 2. My area should be 120 inches squared. Okay, so pretty straightforward. And our last shape that we have is a rhombus. So the formula for rhombus is actually the exact same as the kite. Just so you know, diagonal 1 times diagonal 2 divided by 2. So you don't want the outside measurements, you want the diagonals. For this particular example, it says the area of the rhombus is 54 feet squared. Find the length if RH, or find the length of RH if OM is 12. So if you notice, RH is one of our diagonals, OM is the other diagonal. So we have OM, they say that's 12. And if we want to find RH, we have to plug it in for diagonal 2 in our formula. 54 is going to go in the spot for A because it's the area. So if I want to solve, 54 equals 12 times RH divided by 2. I can do this one of two ways. So I could either simplify and take 12 divided by 2 and leaves me with 6 RH, or I can get rid of this 2 and multiply it to the other side, which is what they did right here. So if we kind of follow their steps, to move this 2 to the other side, it's being divided right now. I got to multiply it. So 54 times 2 would give me 108 equals 12 times RH. And then when I divide by the 12, 108 divided by 12 would leave me with 9. So you could also, like I said, find it the other way. 12 divided by 2 would be 6. Then all I'd have to do is divide 6 to the other side, and 54 divided by 6, well, it's also 9. So multiple ways you can do that. And keep in mind that should be 9 feet. They don't have that necessarily typed in here, but since we are talking about units, that 9 should be feet. Let's make sure they don't have anything else down here. Nope, we're good. So that takes care of all of our area formulas. Like I said, do please be careful when you're entering your units or when you're plugging things into a formula. Make sure that they end up in those spots where they're supposed to go. And then please make sure you are using your algebra skills to solve those correctly. If you have any questions or you need more examples, please let me know. And I will hopefully talk to you soon. Okay.